To divide my polynomials, I'm going to use long division. So with long division, I need to follow my rules of dividing by each place value, multiplication, subtraction, bring down, and start over that we practiced in class. So we're going to have x squared minus 2x minus 15, and I'm going to divide that by x minus 5. Now inside my polynomial, I want to make sure my degrees are starting with the highest degree, and then it walks down to the highest degree of 2 to 1, then a degree of 0 on the constant. So now I will start my division process. Now I can't divide x squared, one term, by x minus 5. So what I'll do is I'll go into my second place value and divide x squared minus 2x. But when I do that, I really want to just focus on what does x squared divided by x give me. So when I focus just on those first two terms, x squared divided by x is just x. So there's the division process. Notice that I indented because I'm into the second term. Then I'm going to start my multiplication process and take x times x minus 5. Well, that will give me x squared minus 5x. But since I have to subtract that, when I come over to my division problem, I'll make sure I distribute the negative and make that negative x squared plus 5x, because I'm going to turn that into subtraction of that whole binomial, and that's going to give me negative x squared plus 5x. Now I will combine my like terms where my first terms should cancel if I did everything right, and negative 2x plus 5x gives me 3x. Now I'm ready to bring down, and I will start over. So I'm going to take that 3x this time and divide it by x. And 3x divided by x is simply 3. It's a positive 3, so I'm going to put a plus 3. Then I'll come over here and complete my multiplication process. 3 times x minus 5 is 3x minus 15, but I have to subtract that, so that will become a negative 3x and a positive 15, and I will go ahead and subtract. I can see my 3x's canceling, even my 15x's canceling, leaving me a remainder of 0. So x squared minus 2x minus 15 divided by x minus 5 is simply x plus 3 with no remainder. Okay, moving on to my second example, I have x squared plus 5x plus 6. And I'm going to divide that by x plus 3 using long division. Again, I'm going to focus on the x squared divided by x, and that's just 1x. I'm going to indent here because I'm dividing by 2 terms, so I want to indent to my second term. Then I'll complete my multiplication of x times x plus 3. Gives me x squared plus 3x. Since I have to subtract that whole binomial, that's going to bring over here negative x squared minus 3x. I'm going to go ahead and subtract. That's going to give me 2x. I will bring down, and I'm going to start over. In the process now, I'm going to take this 2x divided by x, And 2x divided by x is a positive 2. And then I complete my multiplication process. 2 times x plus 3 gives me 2x plus 6. But I needed to distribute my negatives, so both of those become negative. And my 2x's cancel, my 6's cancel with a remainder of 0. And this is going to result in a quotient of x plus 2. For my third example, now it's written a little different if you look. So my example above has my actual division sign here. Notice that in example 5, it's showing it as multiplication, but it's also showing it using that negative exponent. So we remember that a negative exponent means just simply to divide by. Or I can rewrite this as a squared minus 5a plus 3, and I'm going to divide that by 2 minus a. Now, a second complication in this problem is that we don't typically see the variable first or second in my divisor. So I'm actually going to rewrite this one more time, but this time I'm going to flip this and make this a negative a plus 2. All I'm doing is rewriting it so that my variable term comes first in my divisor. So now when I go ahead to write my long division problem, I'm going to have a squared minus 5a plus 3, and I'm going to divide that by a negative a plus 2. Now that negative is going to be a little bit, of a problem when I'm dividing, but I can see that I'm still dividing my a's out, or my first terms out first. So when I do that, a squared divided by a negative a becomes negative a. I just have to pay attention to all of those negatives in my problem. Then I go through the multiplication process of negative a times negative a plus 2, which gives me a positive a squared and a negative 2a. But remember, we have to distribute that negative again to subtract. So that will give me a negative a squared plus 2a. I'll go ahead and collect my like terms. That's going to cancel out my a squareds, leave me with a negative 3a, bring down the plus 3, and then I'll start over. So I'm going to start over with taking negative 3a and dividing it by negative a. So negative 3a divided by negative a is going to give me a positive 3. I'm going to go through the multiplication process. That gives me negative 3a plus 6, but I'll distribute that negative for a positive 3a and a minus 6. So when I go to combine my like terms, my a terms will cancel, but in this problem, I'm going to be left with a remainder. Now, I don't want to write it as a remainder. What I'm going to do is write this as a fractional mixed polynomial. So I'm going to rewrite this as negative 3 over my divisor of negative a plus 2. Now, all those negatives might look a little messy, so when I go through and I rewrite this answer, I'm going to write it as negative a plus 3 minus my remainder, because that 3 was negative in the end, of 3. And I'm going to go ahead and switch that divisor back to what it was originally, that 2 minus a. And that's going to give me my quotient of negative a plus 3 with a remainder of negative 3 over 2 minus a. All right, let's look at another one of those. So this one still has the negative exponent, you see. So I'm going to rewrite this as x squared minus x minus 7, and I'm going to divide this by x minus 3. Now this one doesn't have to be switched in order, but I do have to handle this negative exponent and make this divided by. All right, I will go through the process of starting with x squared divided by x. And when I do x squared divided by x, I simply get x. I'm going to take the x times the binomial of x minus 3, leaving me with x squared minus 3x, but I don't want to forget that I have to distribute negatives. So that will become a negative x squared, a positive 3x, and then I will do my subtraction. The x squareds will cancel. I will have a 2x and a minus 7, and then I start over. I'll take 2x divided by x, which gives me simply 2, and it's positive, so I'm going to make that a positive 2. Complete my multiplication in my long division step, 2x minus 6, and I'll go ahead and distribute those negatives so that I can subtract out a negative 2x plus 6. My 2 x's are going to cancel, and I'll be left with a remainder of negative 1 divided by x minus 3. That's my quotient. Now, for my very last problem, if you remember when I mentioned in the very first problem that my variables have to start with the highest degree and then work their way down. Now, what you see here is that we are missing a degree of 3. So when I go to write my first polynomial inside of that division bar, I'm going to put a placeholder for my third degree term. So I'm going to have 4y to the 4th. I'm going to just represent where my third degree term would go, just in case I need it for lining up my multiplication. Then I'll have a negative 5y squared. I'm just now collecting the rest from my polynomial above, plus 2y to the first, plus 4. Technically, that would be y to the 0, but we're not going to put a y to the 0 in there for our constant, all being divided by 2y minus 1. So now let's start our division process. I'm going to take 4y to the 4th and divide it by 2y. That's going to give me 2y cubed. I'll take 2y cubed and multiply it through 2y minus 1. That will leave me with 4y cubed minus 2y. That leaves me with 4y to the 4th minus 2y cubed. I will distribute my subtraction, and that will give me negative 4y to the 4th, and it looks like I'm going to need that placeholder so that all of my terms line up nicely. Then I start my subtraction, and my 4y's to the 4th will cancel out, leaving me with 2y cubed minus 5y squared on the bring down. I'm ready to start over. I'm going to take my 2y cubed divided by 2y. That's going to give me 1y squared. I'll multiply my y squared through. That will leave me with 2y cubed minus y squared. And then I'm going to subtract those terms, giving me negative 2y cubed and plus y squared. My first two terms will cancel, and I will have negative 4y squared. Now I'm ready to bring down the 2y, and I'm ready to start over. I'll take the negative 4y squared and divide it by the 2y, leaving me with negative 2y. Oops. And I'll do my subtraction over here. Negative 2y times 2y minus 1, giving me negative 4y squared plus 2y. I don't want to forget to distribute my negative for the subtraction. So that gives me a positive 4y squared, which is what I need for those y squared terms to cancel. And actually in this problem, the y terms also cancel. I still need to bring down, but because my degree in my 4 is smaller than the degree in my divisor of 2y, that becomes my remainder. So my remainder is going to be plus 4 divided by 2y minus 1. And that's going to finish my division problem of polynomials using long division. Let me know if you have any questions.